Okay, so we have a composition here and they want us to find the domain, and they give us the two functions. Notice they're using the composition notation, so just note that. I typed these and it should have a space in there, but you could also rewrite it as f of g of x, and I'm going to do that because it might be a better visual for you. Okay, so when you're trying to determine the domain on a composition, first look at g of x, okay? So I'm going to look at g of x and I'm going to say, hey, what would be a problem here? Well, it would be a problem if 3x minus 2 equaled 0. That would be a problem. So you do the solving and you get x equals 2/3. So remember, x can't be 2/3. That's got to be out of the domain. So, we can have lots of numbers. We assume it's all real numbers until we show otherwise. But x cannot be 2/3. Okay, now we're going to go to the f function, and we're going to look at that. So we know that x can't be 1, right? But it's not x that can't be 1, it's g of x, because g of x is what's going to go in, right? Okay, so, think of it this way maybe. F of x, well, f of g of x would equal 5 over g of x. Well, darn it. Having all kinds of problems this morning. G of x minus 1, like that. Okay, so this is what can't equal 1. G of x cannot equal 1. Now, if you're saying, well, wait a minute, why can't it be 1? Because then you'd have 1 minus 1 in the denominator, so you'd be dividing by 0, and that would be a problem. Okay, so now we have to make sure that g of x, okay, this is going to come down in here then, that 4 over 3x minus 2, we have to find out when does that equal 1. Okay, so I would multiply by 3x minus 2. So I'd have 4 equals 3x minus 2, and then I would have 6 equals 3x, divide by 3, and I'd get 2 equals x. Okay, but remember, this is what it can't be. Okay, so I never know whether to use equal signs or does not equals. In the book, I think they used equal signs, but really that's what x can't be. We're eliminating those from the domain. Okay, so we know x can't be 2/3 and x can't be 2. And even though 2 works in g of x, I mean, you could put it in that function. The problem is the output would give us 1, and then we couldn't put that into f of x. Okay, so I'm hoping that makes some sense. So we want to write the domain so that we x does not equal 2/3 or 2. And I want to show you this in the interval notation. So in interval notation then, the domain, oh, you know what? Let me go here. The domain of f of g of x. Okay, so here's how it looks in interval notation. You can have from negative infinity up to 2/3, but you can't have 2/3. Then you can have from 2/3 to 2, but you can't have 2. And then you can have from 2 and beyond to infinity. Okay, so that's the answer in interval notation. You could use set notation as well. I'm looking to see, no, the book uses the interval notation, so that's what I would use as well. If you're having a little trouble seeing this, think about the graph. Here's 0, here's 2, here's 1. Okay, so here's 2/3 maybe. So you're trying to say, hey, I don't want this number, and I don't want this number, but all these other numbers are great. So we're saying from negative infinity up to 2/3, then we're saying all these numbers in between work, and then we're saying all those numbers after work. Okay, so sometimes the graph helps you see the interval notation a little bit better. So we're just pulling out 2 numbers that we can't have here. Anyway, in interval notation, that's how you write it.